Good afternoon. Thank you for joining us today, especially those that are participating in all hours of the day from across the globe. My name is Jeff Donzi with Esri's National Government Sciences team. Today I have the privilege of welcoming you to this session, Making Weather and Data Work for You. As we all know, weather impacts us every day in many ways. Those of you in attendance today are representative of the variety of missions that incorporate weather and climate information in your daily activities. Whether you are working directly for weather agencies that provide predictions and forecasts to save life and property, or you work in organizations that rely on weather information for your businesses, having access to ready-to-use weather feeds is vital to your work. In today's webinar, we want to provide you information about the many resources and capabilities we have been working on to support your work. Through our relationships with organizations like the NOAA National Weather Service, NASA, the National Center for Atmospheric Research, our business partners, and others working in the sector, we've made significant advancements in the ArcGIS platform. In the presentations to follow, you will see examples of that progress. In addition to today's webinar, we hope that most of you will be able to join us at a number of events we have planned at the Esri International User Conference taking place in San Diego this July. We also have a growing and active community on Esri's GeoNet, an online community to connect you with your peers. We'd really like to encourage you to join our sciences group on GeoNet, as this will be one great way to stay connected and hear about all of the weather and climate focused events we are planning over the next few months, like additional webinars and in-person sessions we have planned later in the year. The webinar today features 4 presentations, beginning with Matt Taraldson, an Esri solution engineer and staff meteorologist, who will provide a brief introduction of the core ArcGIS capabilities for working with weather and time series data. Following Matt, Dan Pursuit of Esri's Living Atlas team will give you an orientation of the atmospheric content and applications available in the Living Atlas of the world. Dan will then be followed by John Petter with Esri's disaster response team. John's team utilizes the platform to support natural disasters around the globe. John will demonstrate some ready-to-use templates among the tools that his team employs that are available via the Living Atlas. And then closing today's session will be Jeff Hicks with an EMAC Fernleaf Collaborative, who will present his work from his organization that provide tools for local communities to be better prepared for impacts of climate change. After the presentations, we'll open it up to the audience for questions. And with that, I will turn it over to our first presenter, Matt.
Thanks, Jeff, and I'll switch over here to my screen. So good afternoon here in Central Time, morning for a lot of the others on the line. So my name is Matt Taraldson. I am a solution engineer here at Esri, also a meteorologist. And this is an abbreviated presentation that I gave at the American Meteorological Society conference in Austin this past year. And this talk was meant to highlight how the ArcGIS platform and the software stack of ArcGIS has changed to better suit and make it easier to access weather data. And so as it sits right now, the ArcGIS platform is in what's called a Web GIS pattern. This is the 3rd iteration of how our software has been used, the first being just a desktop GIS analyst who's conducting research and analysis and then passing that information on as a paper map. The second being a client server infrastructure where you had multiple users who'd be accessing a server to create information and share that amongst each other. And now the 3rd iteration, Web GIS, which is both a pattern and an architectural approach. And as you notice here, we have basically 3 tiers of how people access information. The back end, the server, the online content and services, the front end, the desktop, but in addition, web browsers and smart devices. And in between that is what's called a portal, which can be ArcGIS Online or Portal for ArcGIS. And connecting these 3 tiers is our services. And so by having all these components connected, you can change something in the back end in the server or through an online service and the information will simply propagate downstream through the portal to the ultimate end user, whether that be on desktop GIS, a web device, web browser, or a smart device. On the field, push it back up into the server, or you can make edits in the back end and then push it through the system to everyone else. So the portal opens up a new way for users to interact with GIS data. In the past, you had to have desktop GIS to really have a robust spatial analysis capability. There's applications out there and things that help others who would want to use GIS information, but really the portal, something like ArcGIS Online, has been what's enabled a lot of users to come in and have a shared collaborative space to share information. The end result is that what we've been trying to do is open up ArcGIS to not just that GIS professional, that GIS super user, the traditional user, but give all the different users who might want to use spatial information an easier way to get a hold of that information, whether that be decision makers, the general public, scientists. These different components work together in a way to tailor the experience of how people interact with ArcGIS in a way that's easiest for them to understand. So that being said, kind of an overview of where the platform sits, I'm going to talk about how the individual components of what I just talked about have changed mainly over the past couple years to make it easier to ingest and use climate and weather data. So first, I'm going to talk a little bit about online content and services. And weather information and weather data is interesting because there's often so much of it. If you have an entire numerical model output, something like that, there's so much information, and so it limited the ability to share that information to people within a server. If you didn't have the server capability to handle that data, it was traditionally difficult to pass that information around. That's changed with a new service-based architecture in that you can connect your GIS implementation to an outside REST endpoint or an inside REST endpoint or a web mapping service, WMS, and data can stream in through that endpoint into your GIS infrastructure. So you can connect to an external government database, some sort of weather provider. You simply kind of hook up the hose of GIS data, and that data will stream out of their servers into your GIS, and you can customize it to your needs. Here at Esri, we've also built what's called the Living Atlas, and then the next presenter is going to talk a lot more about this, which is a set of services that Esri has curated to basically enable your GIS, if you don't have other information, to use and analyze weather content on the fly. And so here, satellite imagery, active hurricanes, weather radar imagery, that type of thing. And so these are all in real time. The glory of these services is that as they change in the back end, they'll automatically reflect in the front end. So when you have a stream of weather data coming in that's always changing, as that information is updated in the database, it's then pushed through it, and the user at the very end will see the most up-to-date information. That's how you set it up. Now, another thing GIS in particular has been struggling with is the real-time data analytics. Now, weather data also changes rapidly every second, and paper-based maps, as soon as you print them, are no longer up to date. And so how do you enable a workflow that revolves around real-time dynamic weather and climate information has been something that's been very difficult until a couple years ago. So starting with version 10.5, we've taken the server role, the backend server, and we've broken it apart. So ArcGIS server is still around, but instead of having extensions that you'll add on, like the GeoEvent extension, GeoEvent is now a standalone server capability. And GeoEvent server and its brother GeoAnalytics server are both products that are meant to help ingest and analyze real-time information. GeoEvent server is meant to ingest a stream of real-time information. This is a demo that I put together for Utah. And that green dot represents a group of people who are out in a state-controlled forest who are working on doing some silviculture for forestry. And so they're really interested about lightning strikes and safety, obviously, and of course they're at elevation in this example. And so how do you keep safe in this situation? And so there's a lot of solutions out there for apps that will give you lightning information and things like that. But in this particular case, they're in a rural area, there's no cell phone reception, and so that was not a viable option. So what we did is I built this work area in the green, I built a 10-mile buffer, and then I hooked up a lightning stream to this information. You can see the lightning strikes outside the buffer, don't do anything, but as soon as lightning comes within that buffer, it generates an alert to a dispatcher. And that alert through GeoEvent can be a text message, an email. In this case, it's an instant messaging program that a dispatcher will monitor. And then the dispatcher can go on the radio and tell the field crew, there's lightning in your area, you need to seek shelter. And so this is all done automatically. The data is just streaming in, and as long as that lightning strike data does not come within that buffer, no one gets an alert. But as soon as the lightning data comes in, the operator will get an alert and it will trigger an evacuation of the people out in the field to make sure they stay safe. Now, Geoanalytics Server takes that same real-time data feed and takes it a step further. On the fly, as the data comes in, you'll add in analytics that you would typically only have in desktop GIS. So in this example here, these are hurricane swaths, wind radii that are coming in from the respective international tropical cyclone forecast areas. And as the information comes in, the new wind radii is automatically appended onto the track, and then the track is classified into its Sanford-Simpson intensity. So you can see here, all the different tracks are plotted on top of each other, but if you animated this in a movie, it would show the different hurricanes, and the colors would change based on the intensity of the cyclone. Again, this is all automatic. This is being done on the fly, and it's using the same tools that you would traditionally use in something like ArcMap or ArcGIS Pro on the fly in real time with data. So these are two examples of how data that was previously inaccessible in the ArcGIS platform are now easier to ingest and can then be used in workflows down the line for the end user. So switching gears to the top of that diagram, I'll talk a little bit about desktop GIS. And so we have a new, it's not really new so much newer, it's a couple years old, but it's a second desktop client called ArcGIS Pro. And it's a 64-bit multi-threaded software platform. But more importantly, there's a lot of new capabilities in there, including native support for NetCDF and improved support for multidimensional rasters and GRIB and HDF data formats. And so native scientific data can now be easily put in ArcGIS Pro and used with your GIS analysis. And it also supports 2D and 3D conversions. And so 3D obviously would be important in the meteorology space, depending on if you're looking at a pressure level or vertical, but it can also be helpful for just your traditional analysis. So here's Hurricane Matthew from 2016, and I've plotted the Saffir-Simpson scale intensity along with the minimum sea pressure from every advisory. And you can see the track pretty well. You can see how the hurricane ebbs and flows. But I think a more profound way to show that is using 3D analysis. So what I did here is just took that minimum central pressure and normalized it against standard atmospheric pressure. And you can see as Hurricane Matthew moved away from Haiti as a Category 4 storm, even though it was no longer a Category 5, the minimum central pressure actually dropped pretty significantly before the hurricane started to weaken again after it interacted with land. So this is just an example that, 3D is great for upper air analysis and things like that, but even for the traditional analysis, the 3D capabilities of Pro can really help you show a dynamic data set and, show it in a way that's a lot easier for people to understand and showcase some of the variables. So now I'm going to open up a Pro question here, a poll rather, about ArcGIS Pro. And I am curious to see how many of you are actively using ArcGIS Pro. And while you guys fill out the poll, I'm going to switch over and I'm going to do a little bit of demo to talk more about how ArcGIS Pro utilizes scientific data formats. So people are answering the poll, that's good. But here on the left, I have, my left actually, I have ArcGIS Pro, I have a map open. And if I go in and I click this Add Data button, I have some saved data on my desktop. And you can see here .hdf and .bin. These two .bin files are quantitative precip forecast and probability of precip GRIB files. And these second two are HDF MODIS files that I took from NASA. And I'll enter in the QPF. I'll put that in here. And Pro will natively take that GRIB file and will display it. Now here it's kind of ugly because 0 is coded as blue, so you have a lot of blue where there's no precip falling. But what I'll do is I'll move over to another map, and this has been classified, so it makes a little bit more sense. So I'm here in the Minneapolis-St. Paul office for Esri. It's been an active pattern, a wet pattern here for the past couple weeks. And so this is an example of heavy precip. You add in the native GRIB file, and you can see up here the time map is already enabled. It plays like a movie, so I can go forward in time and you can see the precip moving around. And this is all being done natively by utilizing the back-end metadata of the QPF file. This file originated straight out of the National Weather Service National Data Forecast Database, or National Forecast Database, and it's the official human augmented forecast. And so the script file can be interrogated. I can click, and so this is the classified 8, which on the Weather Prediction Center website is greater than 2 inches of rainfall. And so just to give a little bit of, again, this is a grid file, but just to give a little bit of context, you can use this with other vector files. So this is USA urban file from Esri's Living Atlas, and I can go in here. If I zoom in, you can see that the precip remains west of the Twin Cities metropolitan area, and really in rural Minnesota. You can see other cities start to pop up here, and again, I can click that information. It's a vector file format, and I can get information out of that. And so the grid file will work natively by itself just fine, in a way that is a lot easier than what ArcMap could do in the past. And so the only downside is that some of our scientific tools are not fully able to ingest scribs. So what I would do is to use it further for more analysis. I can go to export raster. I can specify the type of raster that I want to output. In this case, I'll use 8-bit signed. Here we go. And it will automatically spit out a TIFF, which I have here, that I can then use as part of a simple raster layer in my raster calculator that's been revamped in ArcGIS Pro as well. So data, is both supported in its native format. It's easier to change over to another format that then can be further used for analysis across the ArcGIS platform. And I mean, these are things that could be done in ArcMap previously, but in Pro it's been made a lot easier and more responsive, and things like NetCDF are now a native format within Pro, so it makes it a lot easier for the end user to use. So now I'm going to go back to the results of the poll rather. I'll share, and you should be able to see the poll results. And so 42% of people said that they have not used Pro at all. 7% are using it every day, and that actually aligns fairly well with how I've asked this question at many of the talks I've given, and that aligns fairly well with how people have responded in the past. So this little pitch was just kind of show you how ArcGIS Pro can be used and how it can really be a meaningful way for you to go through and use ArcGIS to do spatial analysis. Now, I gave a really simple example of how scientific data can be used, and that was just a single grid file. But this can truly be scaled up and support an enterprise level deployment. In this case, using the same tools, we have the high resolution rapid refresh model, or the HRRR. And here we have composite reflectivity and then contours of surface temperature. And this goes out for the entire HRRR cycle, all the way out by every 6-hour time step. And so you can go through and you can look at all the different model variables and plot them all on top of each other. And so it's not just a simple dragging in 1 or 2 files. If you want to put a lot of model data into ArcGIS, the same tools will support that and then can be shared out as they have been here to other users. So just to reiterate, ArcGIS Pro is going forward what we see being our desktop GIS platform. ArcMap is still around, it's still supported, but we really want to start pushing people to start using ArcGIS Pro. It's a more robust software platform. Like I said, it works easier with scientific data format, and it then consumes services and shares services a lot more efficiently than what ArcMap would do. So I'd want you to, if you take one thing away from this talk today, I really want you to push you towards Pro and at least experiment with how it can better help your workflows and change what you're doing with ArcGIS. Now, the third part of what I'm going to talk about is that middle slice, the portal, which could be ArcGIS Online or Portal for ArcGIS. And Portal is another way for end users to interact with GIS data in a similar fashion to what was only possible in desktop GIS. So last year I was approached by our insurance team here at Esri about the feasibility about using just ArcGIS Online to do some spatial analytics. In particular, they're interested about calculating the cost of disasters compared to historical disasters. So I built the prototype. This is the Twin Cities metropolitan area, Minneapolis, St. Paul. And these are historical hurricane tracks placed on top of aggregated median home values per parcel from the University of Minnesota. And so you can see there's a lot of tornado tracks here. In particular, there's one right over the suburb of Edina. This one was from 1952 and covered 70 miles. It was an EF2 tornado. And at the time, it created about $6 million worth of damage in 1952, or about $57 to $58 million worth of damage in 2018. Of course, had this disaster occurred now, it would be about an order of magnitude higher. This area was mainly rural in 1952. Now it's extremely built up, and there's a lot of people that live there. And so the analysis was done strictly using ArcGIS Online, not using desktop GIS. And it was still, it might not be the end result for every user. There's this portal, ArcGIS Online or portal for ArcGIS, that many users can use to create their own maps and do self-exploration and self-mapping in a way that you could only do in desktop GIS just a couple years ago. To illustrate that, many of the tools that were only in desktop GIS have been ported over. I highlighted here the create watershed and trace downstream, which were formerly only in the hydrology tool set, are now available in ArcGIS Online to use. So it's just another avenue for users who don't want to install desktop GIS or don't need to use desktop GIS every day. ArcGIS Online is another available option to use and create maps and to conduct spatial analysis. Along with the ArcGIS Online capabilities, we also have a new tool called Insights for ArcGIS through the portal, both in ArcGIS Online and Portal for ArcGIS. And it's a new user interface. It opens up a new data scientist role for using GIS, and everything is done via drag and drop. So it's getting rid of the menus that you had in ArcMap and the menu constructs that you have in Pro. Everything that is now done is a drag and drop fashion. It's more intuitive for those who've never used traditional desktop GIS. And again, it's getting at this idea that there's a lot of users out there who have different skills with GIS, but still have questions to ask about using spatial analysis. So how can we best address those users and get them familiar with using spatial analysis? And Insights is just another example with a new user interface of how to get that done. So with that, here's my email, and we'll have questions at the end of this, but I'll turn it over to Dan, who will give a further presentation about the living atlas of ArcGIS.
All right, thank you, Matt. So as Matt said, I'm Dan Pursuit, and I'm with the Esri Living Atlas of the World team. As you just saw, ArcGIS Pro can simplify the complexity of working with weather data. But at Esri, we want to make it even easier to get access to information, even if you aren't a GIS professional. So we've taken the work out of prepping weather data for use in GIS by including it in a variety of weather-related web services in what we call the Living Atlas of the World. So right now, I'm going to start another poll, and that is how familiar are you with weather data in the Living Atlas? So go take a couple seconds and respond to the poll. And what we're seeing is not many people have used weather data here in the Living Atlas, which hopefully that means you're going to get a lot out of this presentation as I go forward. So today I'm going to talk about weather and climate data that's available in the Living Atlas and how you can use it in your own applications. The Living Atlas is a curated collection of some of the best data from around the world developed by Esri and the GIS community. It's free with your ArcGIS Online account, and it includes a variety of authoritative weather and climate data. I'd really like to stress now the collaborative aspect of the Living Atlas. This collaboration can come from hosting your own services in the cloud or on ArcGIS Enterprise servers, providing data access and updates for us at Esri to host through the Living Atlas, or simply by working with the GIS community to implement best practices in sharing that data and displaying that data. So weather and climate is actually a subcategory of the environment section in the Living Atlas that we see here. Additionally, you'll find a lot of other related and useful data in the Earth observation subcategory. And when you think about weather and climate impacts, there's of course connections all across the different areas in the Living Atlas. So right now, we're just going to talk a little bit more about the different weather assets that are available. There are over 115 weather and climate data layers in the Living Atlas, contributed by many organizations. I'm just going to point out a few to save time, but once we're done here, I encourage you to browse throughout the Living Atlas, either online or in ArcGIS Pro. As Jeff mentioned before, Esri has a close partnership with NOAA and the National Weather Service, especially when it comes to providing timely weather information. Both the US and in global coverage, we have a lot of data from them. Not only does NOAA contribute many layers and applications to the Living Atlas, but here at Esri, we also run several data sets from them, including global METAR and weather buoys, updating every hour with 11 variables. Common things like temperature, dew point, wind, sky conditions, things like that. The Storm Prediction Center storm reports that update each day. We have the weather watches and warnings that update basically every minute. Tropical cyclone locations and forecasts from the National Hurricane Center and the Joint Typhoon Warning Center, and those update in real time every 4 times a day about. The National, or the US Drought Monitor, the National Digital Forecast Database, which Matt showed a little bit of before, and we have 6 variables from that. And most recently, the National Water Model is also available. By far, one of the most popular data sets when there isn't an active hurricane approaching the US is the collection of stream gauges from around the world. Now, this isn't completely comprehensively global, but we have contributions from many countries and organizations around the world. These gauges are incredibly helpful in identifying areas of inland and coastal flooding. And when you combine them with the hydroshed or the downstream trace utilities, either online or on desktop, you can quickly identify areas that can be impacted by river and stream flooding. And as I mentioned, we have contributions from many countries, and we are continually adding to this feed here from as we get agreements with other organizations to use this data. So one of the strengths of the ArcGIS platform is its integration. And you'll find that the Living Atlas is accessible in just about all of our products, including ArcGIS Pro, ArcGIS Online, and other ones that you may not be as familiar with, such as Collector. So right now I'm going to hop over to the Living Atlas on ArcGIS Online. And when you land on the Living Atlas webpage, you'll find that there's a lot of resources besides the data that are going to be useful. We have blogs and lessons, tips on how to use the data. But once you're on the homepage, you can start either here by searching for a particular data set, or you can go up here to the browse, and this will take you to the heart of the Living Atlas collection. Not only can you browse data sets within a subcategory, so if we only want to see weather and climate data, we can check that. But you can also filter them based on the type of resource. So we have maps, layers, scenes, apps, and story maps and tools, when they are contributed, and the area that they cover. We also have the quote-unquote Esri-owned content, and this means that we curate and ensure the reliability and updates of this data. They're coming here from Esri. From the Living Atlas, you can open a data set. So we're going to click on one, and you'll get more information about that data set. And you'll also get the rest endpoint, which you can use. You can go to directly, or you can copy and paste into your other applications. I'm going to open up this this layer in a web map now. Sign in. Again, you need to have a ArcGIS Online account. And so here we have this this particular data set with thousands of or hundreds of METAR locations around the world. So when you're in a web map, you can either just work with this particular layer, or you can add additional layers, either from your own data, other data that's in ArcGIS Online, and then also you can do that same browse and add from the Living Atlas here. So next, I'm gonna switch over to ArcGIS Pro and show you some of that capability. So let's open up Pro here. So in ArcGIS Pro, you can access the Living Atlas by going down to your Catalog tab. I'm down here in the bottom right, and you'll have your project, and then click on Portal. And this far right icon is the Living Atlas. So if I wanted to type in that same data set, METAR, current weather conditions, I can add that to my map. and it's going to go fetch the most recent data. And here we have that same data that we saw online that's available. Of course, there's 11 different variables here, and so you can really customize how to display that data. And so here's an example where I've taken that data and then symbolized multiple different attributes of it, including temperature, wind direction, and the sky conditions. And then if we zoom in, we can also get some readouts of temperature and dew point. So you can do a lot with this data. But I should point out that the Living Atlas is more than just data layers. When you start browsing through it, you'll find web maps. So this could be a couple different layers that have been saved together as one particular map online. Story maps, of course, are becoming more and more popular. Thousands and thousands have been contributed to ArcGIS Online. We have data applications such as the ones that you're seeing here, like our precip application, the drought monitor application, and the global water balance app that update in real time, and they provide a lot of analytical capability, all contained in one package, so you don't have to do the analysis yourself in Pro or online. And then we have other things such as dashboards and utilities, tools and applications that you can execute in online or in Pro. So I've been kind of getting to this. What else can you do with Living Atlas layers? There's a lot you can do besides mashing them up into web maps. And this is really great because it's a way in which you can take the Living Atlas data and make it your own. You can tailor it for your audience or for your particular organization. So one of the things that you can do, as I mentioned before, is customize the symbology. Now, not all services that are coming from ArcGIS Online or the Living Atlas, depending on who provides them, can be customized, but most of the ones from Esri you can. So if you open up the layers and you see this particular icon, it means that you can change the display characteristics of that data. And this applies to point, poly, and pixel data. If you choose to change the symbology, Smart Mapping will suggest the best options for using either one or two different variables to display in your map. The next thing, you can filter or query your attributes here. So you'll see the little filter icon. And if you open up the table for your data set, you can see what is available to filter or query. You can run a definition query in ArcGIS Pro, or the same thing that's called a filter in ArcGIS Online. So for that METAR example, or the global wind or weather locations, if we wanted to only display those weather stations that are in the United Kingdom, we could do that. Or if we wanted to only display those above a critical threshold of temperature, we could do that. Pop-ups. Most Living Atlas pop-ups are enabled, and it allows you to click on a point and get more information about the data that's underlying that point, poly, or pixel. You can also customize how these pop-ups are displayed, either in ArcGIS Pro or online. You can change how those pop-ups are configured. So if you select the customized pop-ups window, you can choose the attributes to hide or display, and then you can write sentences that then call to that particular attribute for that one feature, and they'll populate in the sentence. So instead of having just a listing, you can have a more descriptive pop-up of the data. And for those more advanced users, you can use arcade language to compute new attributes from your table. So it might be correcting from or converting from Fahrenheit to Celsius, or something along those lines, or adding two different features together, and you can get new attributes to show up in your pop-up. The arcade language is basically the same that you use when you're writing an equation or a formula in Microsoft Excel. Saving a layer, this is something that's relatively new. If you like a layer that's in the Living Atlas or in ArcGIS Online, and you want to save it to your own organization's portal, so maybe you want to customize the description of that layer or the symbology and have it apply to everybody else that might use it from your particular organization. All you have to do is click on the layer, make a copy of it, and then when you open up the attributes of that copied layer, you'll see this option to save the layer. And now it's going to create a clone of that layer within your organization. Lastly, you can run an analysis on a layer. So right now I'm going to switch over to ArcGIS Online again for one more demo. And one of my favorite things to do with weather and climate data is to quickly run an impact analysis, or what I call an impact analysis. So figuring out what populations or aspects of an area are going to be impacted by a weather event, because that's why we're forecasting this stuff, is to understand what's going to happen and how it's going to affect people. So here we have the current National Weather Service watches and warnings. Again, this is updating in real time. But because this map is a summary of all 23 different event types, and they're displayed by the forecast area, some forecast areas are far larger than others. It's hard to get a clear picture of what's going on or how severe they are, especially if one area has multiple events that are happening. But with smart mapping, we can display this data in different ways. So now, in this map, I'm scaling these circles based on the population of the forecast area, and then coloring the circles based on the severity, of the area or of the event, and that's kind of classified by the National Weather Service. So how did I create this map? Well, it's pretty easy. If you're up here in your analysis tool, or if you're on ArcGIS Pro, you can also do what's called data enrichment as one of your analysis tools. So all we have to do is click that. We will get all of our different analyses that we can perform. We're going to choose data enrichment, and of all the different attributes that are in the Weather Service data, I'm going to click size and severity. Add population of the US, the 2017 population. And then we're going to run this analysis. It'll take just a minute. It's going to consume a couple credits, but what you'll end up with is basically these shapes here that you can then go in and choose how you want to style that. So I said we're going to choose population and add another attribute, severity. Smart mapping will suggest how to show this, and then we can go in and change the different options of how things are colored or how the dots are scaled, depending on population. All right, so that's pretty easy. I'm going to pop back over to my presentation. So the basic data enrichment idea that I showed just now can be applied to countless data types using local or online data. It might be your particular data that you load into ArcGIS Pro or into ArcGIS Online. And we can use that to quantify the impact of weather or climate events on lives and property. And with the richness of the demographic data that's provided by the Living Atlas, you can analyze multiple facets of the impact, from at-risk populations to parcels and to commercial property. So hopefully you're beginning to see not just the value of the data that's already in the Living Atlas, but also how contributing your own data will only help other people to get a little bit more situational awareness and improve decision support when it comes to weather and climate data from around the world. And lastly, I should note that over the next year or so, we're looking at making significant improvements to the weather and climate data that you find in Living Atlas, both from here at Esri and then in collaboration with all of our partners from around the world. So we welcome your participation in this progress, and if you have any questions, definitely feel free to reach out to us. And with that, I'm going to turn this over to John Petter with our disaster response program.
Great, thanks very much, Dan. Yeah, thank you very much. Actually, Living Atlas is one of those layers that the disaster response team uses a lot, especially in conjunction with data from the local incident. Can you please switch over to give me control? Thank you. So Esri has a disaster response team. We've been around for about 20 years. Actually just over 20 years, and we're here to help any organization that needs it when an incident exceeds their capacity to respond. That might be additional software or licenses, some technical support on workflows, or even on large scale events, say like the hurricanes last year, we'll actually deploy personnel on site to help. We've been around quite a long time, and these are sort of some of the significant events that we've supported. You can see all the way back from the Northridge earthquake up to the wildfires last year. Disasters seem to be coming more and more frequently, and when they do come, they seem to be getting worse and worse. Again, the hurricanes last year and those terrible wildfires, which we all had as well. So the disaster response team is here to help when you need it. This is an easy chart to show you that the disasters are getting more complex and more expensive. Napa was a big game changer for the state of California and the way they did business. You saw earlier on how the patterns in GIS are changing into a Web GIS, and now Cal OES is one of the leaders in embracing Web GIS throughout the state of California for disaster response, mitigation, and planning. FEMA again uses a lot of our products now. This is an example of a story map that they put out for hurricanes, and this is sort of updated and kept up to date on a constant basis. So you can always go here and see what FEMA's got going on with the hurricanes. You showed Dan showed geo enrichment quickly there. This is one of our templates called the impact summary map, and I'll show you a live version of this. But this takes just that demographic information in the polygons and puts it into a format that can be used for making decisions. The Living Atlas is full of data. We need to make that into information for both the public to consume and decision makers to consume. We do a lot of work with workflows, helping folks with things like damage assessments that they may not have done for a while. If you think of some of the fires in California last year, some of those communities may not have done a damage assessment for quite some time. So the disaster response team helps there with workflows. This is an example of just that through those fires. And lastly, again, this is just showing the dramatic shift in GIS from 2003, all the paper maps everywhere and the presidential briefing. And on the right there, that is in Texas, where the president came in to get a briefing during Hurricane Harvey, and you can see the complete transition there to a Web GIS and web maps. So let's show you how we actually work with this data. So Dan was showing you the Living Atlas of the world, and we use a lot of the feeds in here as base maps and base observations, and to put data in context. So Earth observations is one of the categories we use a lot, and Dan has gone into some of these different data feeds. But again, this is the data, and it comes into a web map. I really need it to become information. The way we do that is by leveraging Esri's solutions template. So we have solutions templates here, solutions.arcgis.com, for about every industry you can think of. Some of the ones that I use more frequently are under the emergency management grouping right here. And these templates are free to download and free for you to use. They cover preparedness, response, and recovery. Under response, we have everything from the impact summary, which I'll show you a live example of, a whole situational awareness suite, emergency maps, road closures, and all the different products, all templatized, that can now be leveraged with the data coming from the Living Atlas. So how can you get started with these? Well, we can learn more about each of these solutions and dig in, and you can see online examples. But there's also a deployment tool made available by the solutions team. So this is a ArcGIS solutions deployment tool, and this is an add-in for ArcGIS Pro. If I switch to ArcGIS Pro, I have a map here with several Living Atlas layers. I've got smoke, and I have the current wildfire features coming in. I just installed the add-in for ArcGIS Pro, and that is available here under the Share tab and ArcGIS Solutions. When I click on ArcGIS Solutions, I'm prompted first to sign into an ArcGIS organization, which I already am. I'm signed into our disaster response organization. Next, I can select a solution that I want to deploy. So this reads all the current solutions available on the solutions websites. So I could look at local government or emergency management and see all the solutions available underneath here. If I wanted to publish a public information map, I can search for that. And I've got different versions of public information maps that I can publish. I've also got a situation awareness viewer, which is another very useful tool. I can simply select this, select a folder in my organization, or type the name of a new one and click the deploy button. This now writes into my organization feature services, web map, and app. And the app might be a web app builder template, a survey 123, or an operations dashboard. It can be anything that made up the solution which you've already scouted on the solutions website. So if I click deploy there, in the deployment, I deployed to weather and climate folder, and I've got a situational awareness web map, a viewer, and a set of reference feature services, feature layers right here. When you open this up into edit mode, you can see that we actually have a fully functional app which has been completely authored and configured for you. It's got the widgets already configured here in Web App Builder, and you have the default functionality of layers and legend and the situation awareness viewer. So I took the web map from this with the Living Atlas layers, and I added a few more pieces of information to it, which are relevant to wildfires. So this is the situational awareness viewer deployed. I can currently look at wildfires that are burning. I know one that is of note right now is the 416 in Colorado. So I use this widget here, the info summary widget, to organize everything. I can click on 416, and it's interesting to understand where 416 is, but more interestingly, what's around it and what might we need to protect. So by using the set location button, I've populated already some information that's been looked up on a buffer around my fire perimeter. I can, for instance, see that there are 4 cellular towers right within this area. This one might need protecting. I can look at electrical transmission lines, and you can see I have an electrical transmission line going right through the fire perimeter. Gas pipelines, other information that is within the fire perimeter. So we use something like this for decision makers to help them make decisions with data coming from the Living Atlas and then supplemented by your own data layer. Some examples about configuring ArcGIS for wildfire. So these are the solutions templates. One here is the public information app. Within this catalog, I can show how the app comes to life to bring data in for public consumption. And by public, I mean this is an easy to use application, not too many knobs and dials to turn. You can provide an overview of what the map is for and some simple layers to turn on and off. We've added to this configuration by adding another widget, which is that info summary widget, which again allows the public to come in, look at their state, understand where the fires are, and get some information on the fires and even link out to the containment, etc. There's an implementation of the situational awareness viewer. And this is the same viewer that I just showed you and deployed directly from the solutions template. And again, I can augment that with additional functionality, additional widgets. Again, that info summary widget is a favorite to be able to easily navigate to those fires. And this is the same app I just showed you. So the other big tool that we have, which we find very popular, is the operations dashboard. So the operations dashboard takes exactly the same map which you just saw for public information, but pulls metrics out of that map as well. So we have map elements around the edge here of this map, and these are totally interactive. So I can interact with any of these and see where the fire is and zoom to these fires. I can also zoom to a particular fire. Again, we'll choose the 416. I've got a small inset map which tells me the containment, the 9, and the number burned. So these are very, very useful products for pulling the metrics out of the map. Some of the other products and templates that we use a lot in conjunction with Living Atlas are some of our time-aware templates. So this is the smoke being animated online in conjunction with the fires. So you can see where the fire is, and then you can see how the smoke moves. And this is a 48-hour forecast. Same goes with wind, and it's the same template underneath, which is the time aware. So you can animate that. We have wind gusts as well. So with the Living Atlas, what we've also created here is a web map that you can be added and opened and saved to your own organization or portal with all these layers available. So we can just open that right up as a web map. Once the layers all draw, I can then hit the save button and save that locally. So it's just the most popular layers that we've found for working for wildfire incidents. Another dashboard here just sort of shows wildfire history over 2018, and it gives you a trend of the wildfires and when and where they were. Again, I can use a filter, and I can filter, say, by California, understand the trend in California, the largest fires, and where they were. We've done exactly the same thing for wildfires that we've done with hurricanes, utilizing the same sets of tools and templates. So the public information map is exactly the same solutions template, which was downloaded and installed and instantiated with Pro, except we're just adding different layers to this one. So this would be the active hurricane and cyclone. We've got some weather radar on here as well. The situation awareness viewer, again, is exactly the same deployment of that solution, but it's just in context of hurricanes. The stream gauges, as you heard earlier, is a very popular application. So by using some of those same templates, I can now filter stream gauges by major flood stage, and I can actually look at what those are and get a real-time feed, and even link out back to NOAA to get the actual real-time information on the flood gauge. And again, in this sort of configuration story map, we've added a precipitation forecast app. Again, the Living Atlas layers that are most useful. And we also have a historic hurricane dashboard available as well, so that we can look at all the storms throughout the course of the year. And then we can even sort of zoom in and look at a particular storm, understand its pattern and its path as it went from a tropical depression up to a tropical fall hurricane and then back down again. So within the disaster response program, this is the impact summary map that we created. This is the snowfall totals, and by looking at any of these polygons, I can enrich that as shown earlier and understand the population underneath any of these. I can choose on the left a different polygon by different depth of snow, so I can see who's in the 21 inch, what my population is, and what the sort of mass understanding of businesses and population beneath that. An incredibly powerful tool for decision makers. Again, you can do that with any shape. So this is a hurricane forecast cone, and as that comes on shore, we can again look at what the impact of that would be as it comes on shore. So if you actually need help from the disaster response team, go to Esri.com and industries and click on disasters. And there's a button right here for request assistance. And we'd be more than happy to help you if an incident's exceeding your capability to respond. With that, I'm actually going to turn this now over to Jeff Hicks. Go ahead, Jeff.
Great, thank you, John. Wonderful. Okay, thank you. So my name is Jeff Hicks. I'm the lead analyst and CEO of the NEMAC Fernleaf Collaborative. We're a public-private partnership that delivers local government resilient solutions on the ArcGIS platform. Today, I'm going to talk about a project we're very proud to be involved with, and that's the U.S. Climate Resilience Toolkit. I recognize that many people on the webinar are international, and so much of what I will show is certainly directly applicable internationally, but some of the more US-centric tools are a demonstration of some best practices in making decision-relevant climate data more broadly usable. So what's the problem? The challenge our communities face is really threefold. First, we're seeing rapid urban growth leading to changing demographic and land cover that's altering sort of our existing realities. Second, as John pointed out, we're simultaneously seeing a steady increase in the number of billion-dollar climate and weather disasters. 2017 in the US broke all records, and this is on top of an already especially challenging decade. The consequence of that is that we're seeing a shortfall in money to cover these events, both at a federal and at a private insurer level. And these losses then are often absorbed by our communities themselves. And so given these first two challenges, a third challenge is beginning to emerge, and that's that bond ratings agencies are taking note and will begin downgrading local government, their credit ratings, making it more costly to borrow unless they can demonstrate that they're becoming more resilient to these challenges. So before we talk too much about resilience, I feel we should define it a little further. We tend to think of community capacity as a relatively stable baseline through time. But when a hazard occurs, it can knock us pretty far off of that baseline, and it takes us a long time to recover to our previous level of capacity. So when we think about resilience, resilience is about making the right investments, this green triangle on the left side there, ahead of a hazard so that we don't get knocked so far below a critical threshold that we can recover much faster. So realizing the power of resilient thinking to help protect property and save lives, a federal collaboration was established around resilience, organized by the U.S. Global Change Research Program, with the objective of bringing together the disparate federal resources that address all things climate resilience into one central resource. One very important component of that is the U.S. Climate Resilience Toolkit that's hosted and facilitated by NOAA, the National Oceanic and Atmospheric Administration. Our team at the NEMAC Fernleaf Collaborative has developed many parts of the toolkit, and I'm going to give you a guided tour of some of the resources within to draw your attention to help you better understand and find ways to take action for resilience. So you can visit the website at toolkit.climate.gov, and on my screen right now is a screenshot of the home page. One particular resource I want to draw your attention to at the top there is the Steps to Resilience, which is a climate resilience framework that helps to move from understanding climate stressors and threats, quantifying the climate vulnerability and risk, helping to identify options to build resilience, prioritizing those that are most effective, and finally taking action to build resilience. The Steps to Resilience is a central feature of the Climate Resilience Toolkit and helps to orient a lot of the content that's found within. So please check out the videos that describe each one of the steps in detail. These are great resources that describe resilience theory and are certainly applicable internationally. Within the toolkit as well are over 100 case studies showing how communities, companies, and people are building resilience across the nation. This is what a typical, so that previous screen was looking at a sort of a collection of case studies there, and this screen shows what a typical case study looks like in detail. A few things to draw your attention to in addition to the narrative, and oftentimes they have a video associated with each one. There is also the Steps to Resilience is highlighted to show where we are in the process, what tools have been used, and kind of some of the topics that falls under that. I'm going to demonstrate the Climate Explorer which is a central tool to the Climate Resilience Toolkit that we've been very actively involved in, and it's something that you all can use yourself. So this is the toolkit website. I can click this, use the updated Climate Explorer. You'll see a link here that says launch the latest version of the Climate Explorer. You'll notice that this is now hosted at nemac.org, but this is the official tool, Climate Explorer here. One thing that's happened in the latest update is we've updated the underlying climate data now to use the latest downscaling methodology called LOCA, and that's been powered by the ACES platform out of Cornell University, the Northeastern RCC. So within the, and the other big thing I should mention as well is that we've updated it as well to use the ArcGIS JavaScript API under the hood. So this is now on the ArcGIS framework. So there's 3 ways to get at information in the Climate Explorer. And I'll start by diving in on the first, which is to search by location. So I can type in, I'm going to type in Durham, North Carolina, where I'm from originally. And we can see a number of different things that are made available then on this page. So we see temporal data showing hindcast runs of climate models, showing the range of these models back in time, and then 2 different possible futures shown by 2 different emission scenarios, a high scenario and a lower emission scenario. In addition to a variety of these factors like maximum temperature and minimum temperature, there's a number of other derived variables like days with maximum temperature per year over 105 degrees and how that might increase into the future. Similarly, with each one of these presentations, you can see on the right here, we can also open up a map. Again, this is powered by Esri to then see this is a map that's centered around Durham County, where I searched for, and it's interactive. We can sort of see between the historical on the left side and then these higher emission scenarios in the future to see how that's presenting itself spatially. Now, it's not just temperature. There's a number of precipitation and other derived variables that are available in here, all plotted temporally and spatially in the map. Another way to view the information is to look by variable. So you'll see here the full run of variables that we saw there. But if we open that map now, so it gives you a little detail about what we'll see. And then again, this is the same map viewer here, but now it's being presented across the entire country. And so we can see again how the count of these days that exceed this threshold of 95 degrees Fahrenheit, how that's changing through or may change in these different emission scenarios. Each one of the counties is still selectable, so we can pull up a chart of these time series by selecting a county on the map. And finally, there's a third section here, which is weather and tidal stations. There's a few different options that we can pull up here. So this daily versus climate is pulling in station locations for the Global Historical Climatology Network, and we can select a station and then see these daily observations going back in time plotted with respect to the normals, the long-term climate normals. So on the right, as we're looking at precipitation, we can see some of these times of more than normal precipitation on a yearly cumulative basis versus some of these times where we're under what's normal, seeing potentially times of drought. In addition to seeing the data in that form, we've also added some functionality to be able to interrogate the same data, but looking at it in terms of thresholds. And so these are totally user configurable. So we can see, okay, how many days per year do we exceed, say, 3 inches of precipitation at this location, and we can see how that plays out through time, along with a variety of other variables that you can interrogate the information on this threshold basis. A third station type is high tide flooding. And so this is some new, based on some newly published data out of NOAA, a scientist called Billy Sweet, where as we select one of these tidal stations, we can see a count of days of high tide flooding historically back through time, and then based on those same emission scenarios into the future, how many days of year may experience high tide flooding at this location. And again, this is available certainly on the East Coast. I'm focused on the East Coast because that's where I live, but we have the West Coast, Hawaii, and Puerto Rico. So where we're going from here, one thing I should mention is, the Climate Explorer is certainly one part, again, of the steps to resilience of thinking about thinking through the resilience process. Specifically in the Climate Explorer, now that we've transitioned the software to the ArcGIS platform, we're excited to be expanding the integration of Living Atlas and bringing case studies to life with story maps. I want to give a big shout out to Luann Dahlman at NOAA, who's been working on a story map that walks you through the Climate Explorer and the functionality that's in there. And I think this story map will be in the Living Atlas soon. So I think that's all I have for today, and I will pass it back to Jeff Donzie, who will close us up.
Thanks, Jeff, for all the work that you and your colleagues are doing at the Fernleaf and NEMAC Collaborative, supporting local climate resiliency. It's fantastic. And thanks to all the other presenters today, and to you all that are still online. We hope that you've learned a few key things from today's webinar. First, that there is a wealth of data and applications available via the Living Atlas of the world and through access to the Esri platform. In addition, that you do not have to be a scientist or meteorologist to work with this data in ArcGIS, but if you are, we have advanced capabilities that will support your work. And please don't forget to visit the Esri's Sciences GeoNet group. This is where you'll find the latest and greatest weather and climate content from Esri and other folks from outside who are participating, and be able to stay up to date on events we have planned throughout the year. Thank you very much for joining us today.